So friends, we want to find out the support reaction of the beam shown in the figure. So if you look at the diagram, we have got a beam AB having overall length 6 meters. Now the end A of the beam is hinge support, while end B of the beam is provided with a roller support. There is a force of 100 Newton acting at point C, and it is inclined at angle 60 degree with the length of the beam. In addition to that, we have got a moment acting at point D, and the magnitude of moment is 90 Newton meter. So we want to find the support reactions at point A and point B. As we know that the point A is going to have two reactions because it is a hinge support. So you will be having a vertical reaction at point A as well as a horizontal reaction at point A, while point B will have only vertical reaction because it is a roller support. So in order to find the support reaction of this particular beam, we shall draw the free body diagram initially. So let's draw the free body diagram of the beam AB. So in the free body diagram, we will only show the forces acting on the beam, but we do not show the support condition. So let me draw the free body diagram just to make it more clear. We have beam AB. At point A, we shall be having two support reactions. One is vertical and one is horizontal. And at point B, we'll be having only the vertical support reaction. So at point A, we have vertical reaction, that is RA vertical, and we have horizontal reaction RA horizontal. At point B, we have only vertical reaction, that is R. Now at point C, we have got a load of 100 Newton acting on it. So this 100 Newton force is making angle 60 degree with the length of the beam. So we can resolve this 100 Newton load in horizontal as well as vertical directions. So the horizontal component would be 100 cos 60, while the vertical component would be 100 sin 60. Now we have a point D. There is a moment acting at point D, and the value of moment is 90 Newton meter. So this is called as the free body diagram of the beam AB. Now since beam is in equilibrium condition, we have to follow the condition of static equilibrium. So by condition of static equilibrium of beam, that is summation of forces in the horizontal direction, that is I can call x direction, is 0. So if you look at here, in the horizontal direction we have force RAX, which is towards right. So towards right I am taking positive, and we have force 100 cos 60 towards left, but that is the negative. Left we are taking as negative, and that is equal to 0. So if you solve this particular equation, you will get the value of RAH, that is horizontal reaction at point A. So we shall be getting RAH as 100 cos 60, that is equal. So if you look at that, cos 60 is turned out to be 1 by 2. So the value is going to be 50. So now we have used the condition of static equilibrium and summation of forces in the horizontal direction, and we got the horizontal reaction acting at point A as 50 Newton. Now we will use another condition, which is summation of forces in the vertical direction, and that is Fy, forces in the vertical direction, equal to 0. Y direction is the vertical direction we are taking, and x direction is the horizontal direction. So the vertically the force is RAV acting upward. So upward we take as positive. So it is positive because it is acting upward direction, friends. 100 sin 60. So it is acting downward. So minus, it is acting downward. And RB is acting upward direction. So plus RB because it is acting upward direction, equals 0. Now you have to be very careful here. This moment cannot be considered when we take the summation of forces. This 90 Newton meter moment would only come into the picture when we take the moment about any particular point. So since we are only doing summation of forces, so for summation of forces there is no requirement of considering moment, which is 90 Newton meter acting at point D. So now if I simplify this, so you will be getting an equation of RAV and RB combined together, and which is equal to 100 sin 60. To calculate 100 sin 60, you will get, so the value turn out to be 86.60. So we shall call this as equation number 1. We can use it later. This is the second part we have done. Now third part is, in order to find the support reaction at point A and point B, we shall be taking moment about any of these 2 points. So I shall take summation of moment about point A equal to 0. You can take moment about any point. By definition, the summation of moment about any point would be 0. But for simplicity, we shall take about point A or point B where we have unknown quantities acting. So the third point would be summation of moments about point A. Let me take, that is 0. Please remember, in this situation we have a sign convention. We follow clockwise moment. So when beam rotates in the clockwise direction, we take it as positive moment, and if the beam rotates in the anti-clockwise direction, we take it as a negative moment. Okay, we are going to hold beam at point A and we are going to apply the force. Now if you look at RAH and RAV, both of these two are passing through the same point A, so their moment is going to be 0. So if the force is passing through the same point about which we are finding out the moment of that force is going to be 0. So there won't be any moment of RAH and RAV. So you'll have moment of force 100 sin 60. So 100 sin 60 would act at point C, and it is going to rotate the beam in the clockwise direction like this. That is going to be taken as positive. So moment of 100 sin 60 would be 100 sin 60 into length AC. Length AC is nothing but 4 meter as shown here. You can see in the diagram. So it is going to give you positive moment plus 100 sin 60 into AC. AC is 4 meters. Now next, this 100 cos 60 is going to pass through the same point A. The line of action of 100 cos 60 is passing through the point A. Therefore, the moment of 100 cos 60 would be 0. So only the moment of 100 sin 60 would act. Now 90 Newton meter is acting clockwise. It is going to rotate beam in the clockwise sense. So that is again positive. So plus 90. And now RB is going to rotate the beam in the anti-clockwise direction. The beam, because of RB, beam is going to rotate in the anti-clockwise sense, something like this. So it is going to be negative, friend. Minus the moment would be RB times our distance AB. So AB is a distance. So AB value is 4 plus 1 plus 1, that is 6. So this is basically clockwise. If you can see here, this is again clockwise, and this is anti-clockwise moment. So that is going to be 0. To simplify this, from here you will get 6 times RB equals 100 sin 60 into 4 plus 90. That is 436.41. So the value of RB is going to be 436.41 divided by 6. So that would give you the value of RB as 436.41. That divided by 6. So 72.735. So we got the value of reaction force acting at point B, which is 72.735. Now if you can substitute the value of RB in equation 1, so you can get the value of RA from there. So you can get the equation of RAV, which is support reaction acting in the vertical direction at point A. So that if you substitute, let's see what value will turn out. So substituting value of RB in equation 1, and that will give you RAV, that is vertical reaction at point A, that is 86.60 minus RB, which is 7.75, that is equal to, let's see what value it comes. So 86.60 minus 72.735, that will 13.865. So we got vertical reaction at point A also. So we got the horizontal reaction at point A as 50 Newton, and then the vertical reaction at point A also, then reaction at point B. So by following this simple procedure, you can find out the support reaction at point A and point B. Thank you very much.